Hello to you Python project developers! I already started this video asking for your like and your subscription on this channel. In this third video, I will talk about thermodynamic cycles and how you can program the cycles using the Python language. You know, there are many types of thermodynamic cycles, but here I will focus specifically on 4. Kernel, Otto, Diesel, and Stirling. The Kernel cycle contains 2 adiabatic and 2 isothermal processes. The Otto cycle contains 2 adiabatic and 2 isochoric processes. The Diesel cycle contains 2 adiabatic processes, 1 isobaric and 1 isochoric. The Stirling cycle contains 2 isothermal and 2 isochoric processes. In ideal gas, you have equations that represent the process is adiabatic or isothermal. They are P equals K divided to the power gamma for an adiabatic process and P equals K divided by V for an isothermal process, where P equals pressure, V equals volume, and gamma is a constant equal to 1.66 for a monatomic gas and 1.44 for a diatomic gas. Let's start by talking about the Kernel cycle. The cycle has 2 isothermal processes and 2 adiabatic processes. In the isothermal process, in 1, the volume goes from Vmax to Va and the pressure varies as P equal K1 divided by V. The value of Va will be given in the program and K1 can be determined at point D, that is K1 equal Pmin times Vmax. Process 2 is adiabatic and the equation is given by P equal K2 divided by V to the power gamma. And how to determine K2? We can match the process equations 1 and 2 and get K2 easily. K2 equal Va to the power of gamma minus 1 times K1. The volume varies from Vmin to Va. Moving forward, you have an isothermal process. The volume goes from Vmin to Vc and the pressure is calculated by the equation P equal K3 divided by V. The constant K3 can be determined at point B, that is K3 equal Pmax times Vmin. For the next process, that is adiabatic, it is necessary to find Vc. Point C is the point in common between an isothermal and an adiabatic process, and therefore the Vc volume can be found by matching the pressure equations. Vc equal K4 divided by K3 to the power 1 divided by gamma minus 1. And how to determine K4? Make the selection of point D, that is K4 equal Pmin times Vmax to the power gamma. The volume varies from Vc to Vmax and the pressure is calculated by the equation P equal K4 divided by V to the power gamma. In the Otto cycle, you have 2 adiabatic and 2 isochoric processes. Let's start at 1 with an adiabatic process. The pressure varies as P equal K1 divided by V to the power gamma. K1 can be calculated with reference to point D. K1 equal Pmin times Vmax to the power gamma. In 2, the process is isochoric, that varies from Pa to Pmax. But who is Pa? It is the pressure of encounter between the adiabatic and the isochoric process. So, PA equal K1 divided by Vmin to the power gamma. The next process is adiabatic. The pressure varies as P equal K3 divided by V to the power gamma. K3 can be calculated with reference to point B. K3 equal Pmax times Vmax to the power gamma. In 4, we have an isochoric process where the pressure varies from Pc to Pmin. But who is Pc? It's the pressure of encounter between an adiabatic and isochoric process. So, Pc equal K3 divided by Vmax to the power gamma. In the diesel cycle, you have 3 different processes, 2 adiabatic, 1 isobaric, and 1 isochoric. In 1, the process is adiabatic, where the volume varies from Vmin to Vmax. The pressure is calculated as P equal K1 divided by V to the power gamma. K1 can be calculated using point A or D. Let's take point D as reference. So, K1 equal Pmin times Vmax to the power gamma. In 2, the process is isobaric, where the volume varies from Vmin to Vb. Vb being a value that must be supplied. In 3, the process is adiabatic and the pressure is calculated as P equal K3 divided by V to the power gamma. The value of K3 can be found by the equation K3 equal Pmix times Vb to the power gamma. The volume varies from Vb to Vmax. In 4, the process is isochoric and the pressure varies from point C to point D under the same volume as Vmax. The last cycle is a stirring where we have 2 isothermal and 2 isochoric processes. The stirring cycle and the Otto cycle are visually similar. However, in the stirring cycle, there are 2 isothermal processes, and in Otto cycle, the 2 processes are adiabatic. In the isothermal process 1, K1 can be found by choosing point D. K1 equal Pmin times Vmax. The equation is 1 is given by P equal K1 divided by V, where V varies from Vmin to Vmax. In the isochoric process 2, the volume is constant in Vmin and the pressure varies from Pa to Pmax. To determine Pa, choose process 1. Pa equal K1 divided by Vmin. In 3, we have another isothermal process and K3 can be determined by choosing point B. K3 equal Pmax times Vmin. The volume varies from Vmin to Vmax, and the equation 3 is given by P equal K3 divided by V. In 4, the process is isochoric at Vmax and the pressure varies from Pc to Pmin. But who is Pc? To determine Pc, we take process 3. Pc equal K3 divided by Vmax. Now we need to put all this information in the script. I start by importing matplotlib point pyplot and numpy. I want to set the maximum and minimum pressures. Therefore, I considered that the minimum pressure Pmin is 2 times 10 to the power 5 and the maximum pressure Pmax is 20 times 10 to the power 5. The maximum volume Vmax will be equal to 0.05. The constant gamma is 1.66 because it is a monoatomic gas. Let's start with the kernel cycle. I create a subplot because the four graphics will be created together. The volume at the point A is 0.012. From there, I started to write the formulas for each of the process. Remember that I divided the pressure by 1000 so that the scale would not be so large. The constants of each process are K1C, K2C, K3C, and K4C, and the volume variation is represented in V. In this part, I inserted the information about the graph, title, x names, grids, and the beginning and end of each x value. The next cycle is auto. I put the minimal value as 0.02. I inserted the equations for each process and its limits. When there is isochoric process, the variation should be in pressure and not in volume. In the diesel cycle, VB equals 0.02. For each process, I inserted the constants, the equations, their limits, and the information in the graph. I did the same thing for steering cycle with a Vmin value of 0.02. Let's get the program to run so you can get the four graphics. Note the V1 is limited to the minimal and maximal pressure and the minimal volume. This makes it easier to compare cycles. If you have any questions, you can write here in the comments that I will answer. I hope you learned a little and also liked the video. See you soon! Bye!